logs and exponential functions being inverses of each other. So when you graph the inverse of a function, graphically what it is, it's the reflection over this line y equals x, this 45-degree line. So if we reflect this graph over the line y equals x, what we get is the logarithm graph, okay, the logarithmic graph. And what you can see here is that with the exponential graph, it gets closer and closer to the x-axis. This is an asymptote, okay, a horizontal asymptote. The log graph, though, gets closer and closer to the vertical asymptote, the y-axis. Okay, so the domain is x is greater than 0. See this graph here, it's greater than 0. And it goes down to negative infinity, it keeps going up to positive infinity, so the range will be all real numbers. Okay, this graph goes up faster and faster, the log graph goes up slower and slower, but it does keep going up to the right there. Okay, so let's look at some specific examples now. Let's say we want to graph y equals log base 2 of x minus 1 plus 3. Okay, what does the 1 and what does the 3 do to the log graph? Well, we know from other functions that this graph is going to shift the graph 1 to the right. See, it's the opposite of the sign. If this was plus 1, it would be 1 to the left. Minus 1, it's going 1 to the right. 3, it's shifting up 3. Okay, and it's a log base 2. So what we're going to do is, excuse me, we're going to graph the graph here, and we're going to shift everything right 1 and up 3. Okay, so what I'm going to do, because this is an asymptote right here, this vertical asymptote is also going to shift right 1. I'm going to draw in that asymptote right there. This is the equation x equals 1. Okay, that's the equation of the vertical asymptote. So right 1, up 3. I'm going to put a little open circle here. This is not necessarily a part of the graph. It's just a little helper, okay, a little indicator that we're going to graph from this point instead of the origin. So now what we're going to do is we're going to look at the parent function, y equals log base 2 of x, and we're going to graph some points from here because it's been shifted right 1 and up 3. Now let's take a look at this graph here. So what I would do, okay, is I would exponentiate both sides of this equation. So the log base 2 and the exponential base 2, those are inverses, they cancel. So now what we have is, let's write it over here, x equals 2 to the y power. Okay, so if we make a table, -1, 0, and 1, 2 to the -1 is 1/2, because the negative takes reciprocal. Anything to the 0 power is 1, and anything to the first is 2. So what we're going to do is we're going to graph these coordinates, x, y coordinates, from this point right here. So we're going to go right 1/2, okay, down 1, right 1, up 0, right 2, up 1. So you can see this graph's actually going to go like this. There's our log graph. It's been shifted right 1, up 3. So now the domain is going to be x is greater than 1, and the range is going to be all real numbers because this goes down to negative infinity, up to positive infinity. Okay, so we'll do one more example, and we'll take a look at another one. So let's take a look here. Let's erase this. Okay. Okay, say for this example, we want to graph y equals log base 3 of x plus 2 minus 4. Okay, what do the 2 and the -4 do to the graph? Left 2, see the opposite, left 2, down 4. This one has the same effect as the sign. This one has the opposite effect of the sign. So this graph's going to shift left 2, there's our vertical asymptote, down 4. So we're going to think of that as our starting point right there. And now we're going to focus in on the parent function, okay, before the translation, the parent function. We're going to exponentiate both sides using the base 3 because exponential functions and logarithmic functions are inverses. These are going to cancel, and we have 3 to the y equals x. So let's make a table. Let's substitute in for y instead of for x. So we've got 3 to the negative 1, 0, 1, and 2. That's 1/3, 1, 3, and 9. And if we plot these points from here, we've got 1/3 to the right, down 1, right 1, up 0, right 3, up 1, and right 9, up 2 over here. Okay, so if you see the graph, it looks like that. Okay, so the domain is x is greater than -2, and the range is all real numbers. Okay, so that's the log graph. We'll take a look at some more aspects of logs in the next video.